It is indeed possible to obtain a 240 or 220 volt supply from a 480 volts panel, and the key to achieving this lies in the use of a transformer. A transformer serves as a pivotal device in electrical circuits, facilitating the transfer of electrical energy from one circuit to another through a process known as inductive coupling. This coupling occurs between the transformer's coils. Essentially, electrical energy finds its way between these coils via the medium of a magnetic field. These transformer coils are carefully wound around a core composed of a ferromagnetic material, often iron. This core plays a vital role in concentrating the magnetic field, thereby enhancing the efficiency of the energy transfer. To step down the 480 volt supply to either 240 or 220 volts, a specific type of transformer is required, known as a step-down transformer. This type of transformer is characterized by a primary winding that features a greater number of turns compared to its secondary winding. When the primary winding is connected to the 480 volt supply, a magnetic field is generated within the core. This magnetic field, in turn, induces a voltage within the secondary winding. Crucially, the voltage induced in the secondary winding is lower than that of the primary winding. The relationship between these voltages is directly proportional to the ratio of the number of turns in the windings. Let's consider an example to illustrate this principle. Suppose the primary winding of the transformer has 480 turns, while the secondary winding has 240 turns. In this scenario, the voltage induced in the secondary winding will be 240 volts. This direct proportionality allows for precise voltage reduction. Similarly, a transformer can be employed to derive a 220 volt supply from a 480 volts panel. However, it's essential to recognize that the transformer used for this purpose will differ from the one used to obtain a 240 volt supply. The key difference lies in the ratio of turns between the primary and secondary windings. The transformer designed for a 220 volts output will still have a primary winding with more turns than its secondary winding, but the specific ratio between these turns will be tailored to achieve the desired 220 volts output. It is important to emphasize safety precautions when working with electricity. Firstly, always wear appropriate personal protective equipment, including gloves and safety glasses to safeguard against potential electrical hazards. Secondly, ensure that the power supply is completely turned off before commencing any work on electrical equipment. This step is crucial for preventing electrical shocks and ensuring a safe working environment. Understanding the principles of transformer operation and adhering to safety guidelines are essential for successfully and safely obtaining lower voltage supplies from higher voltage panels.